We're going to look at exponential rules. This is from our vocabulary. When a number, a variable, or expression is raised to a power, the number, variable, or expression is called the base. And the power is called the exponent. So is my exponent the b or the n?
N.
Very good. Yep. That little number being raised is my exponent, and the big number that's being raised to that power is the base. An exponent means you multiply the base by itself that many times. Mathematicians back in the day were famous for being lazy. This is actually one of those good ones, because x to the fourth power is x times how many? 1, 2, 3, 4. Who wants to write that when you can just write x to the fourth? 2 to the sixth power is how many 2's?
6.
6. 1, 2, 3, 4, 5, and 6. Yes. So this is one of those moments where the laziness actually helps us out. 64. The invisible exponent. When an expression does not have a visible exponent, its exponent is understood to be 1. Once again, mathematicians are lazy. You would kill yourself if you had to write 1 power every time. Think how many times you have to write that 1 power if you had to write it. Well, let's just assume that anything power to a 1 is just going to be there. So any variable that you see that's by itself without any exponent, it's assumed to be a 1. Our rule number 1, when multiplying two expressions with the same base, you add the exponents. So b to the n times b to the m is equal to b to the n plus m. Adding the exponents. For example, if I have x squared times x to the fourth, it's the same as x to the what?
2 plus 4?
2 plus 4, which is
6.
6. Say I didn't want to be lazy math and write this out. x2 is how many x's? 2. And x4 is how many
4.
x's? 4. Count them all up by counting, you're adding them all up, right? And it's 6. That's why we're adding the exponents, because you're adding how many times you see this. And then this other one, 2 times 2 squared equals, what's this exponent?
1.
1. We add the exponents, right?
Oh.
Oh, don't forget about that invisible exponent 1. So yes,
I forgot.
2 to the power of 3, which of course is 8. What about h to the 3 times h to the 7? They have the same base, so we can go ahead and add the exponents. Gives us h to the 10. So multiplying, you add the exponents. What do you think happens when you're dividing? Subtracting. Opposite of multiplying and dividing, opposite of adding is subtracting. So if I have b to the n divided by b to the m, I could put that under the same base with n minus m. Notice I'm subtracting the numerator from the denominator. For example, if I have x to the fourth divided by x squared, 4 minus 2 is 2. You saw this probably in middle school. I have 4 x's on top and 2 x's on the bottom. What happens when you have something on the same on the top and the bottom?
Oh, you cancel that.
Cancel, or technically it's called reducing to 1, but it looks like you're canceling. And how many x's are left over? 2. So that's why you're subtracting, because you're actually ending up canceling them out or reducing to 1. So what about this one? H to the 6 over h squared?
6 minus 2.
6 minus 2?
4.
H to the 4. Very nice. Rule number 3. When you're raising a power to a power, you multiply the exponents. So b to the n to the n m power, I can write that the same base as b to the n times m. You multiply the exponents. So x squared to the fourth power is x to the 2 times 4, x to the 8. 2 squared, 2 times 2 is 4, 2 to the fourth, 16. Again, this is just a really quick way of not being lazy. If I had x squared is x times x, and how many x times x's do I have? 4 of these. count all my x's, I have 8. So the reason why we have exponent rules is so that we can make our math a lot quicker. H cubed squared is 3 times 2 is 6, H6. Please note that you can't use this rule if there's an addition or subtraction inside here. We must follow order of operations, which says exponent comes second to what? Parentheses. So you have to perform this operation first. Notice we can't because we have a variable before you do the exponent. So there's no distributing. You can't give it the d. It's not equal to this. We'll have to use FOIL, which we'll see next week. You can, however, distribute if it's multiplication, because that's all we're doing with exponents anyway, is multiplying. So if I have a to the b to the m power, I can rewrite that as a to the m and b to the m. I can separate it out as separate exponents. Likewise, xy squared, x squared, y squared. These are equal. Notice they're not bounded by addition and subtraction, an operation I have to do first. Multiply. Which order of operations? Can you do exponents before multiplication?
Yes.
Yes, that's why we could pull this off. Can't here. Parentheses says first. I can't here because exponents come before multiply. And hk to the third power is h3, k3. That's just another version of power property. And again, can you distribute?
No.
No. If I'm dividing a over b to the m power, does exponents come before division?
No. Oh, yeah. Wait,
Yes.
exponents come before it, yeah.
Yes. So you get a to the m over b to the m. You can separate it out as an exponent. So if x over y cubed, that's the same as x cubed, y cubed. My favorite one. Can't tell you how many students put that a to the 0 equals.
0.
Oh my God.
So is it not 0?
I said that.
1.
I said 1.
Like I was about to say, I don't know how many students put 0. You're somewhat close. I think you on the way. Anything raised to the 0 power is 1. I have been famous for putting on a test a problem that takes you 10 minutes to work. Something as crazy as this. 4a squared b cubed whatever raises all to the 0 power, and it is what?
1.
It should take you 1 second to do this. It is 1. I like to see the ones that try to do this all on the side, and then when they get on the outside, they realize that it was all 1. The whole time and wasted all of it. Now, maybe this will help you remember that anything raised to 0 power is 1. Why in the world does that work? Let's take this. Is this the correct statement? A divided by A equals 1. Is that true? A over A is 1. True or false?
True.
True. Anything over itself is 1. What power do I have with A? It's a 1, right? We know that if that power is not there, it's an invisible 1. So this is also true. A to the first power over A to the first power is 1, right? We are dividing exponents, so you do what with the exponents? Subtract. So I can take this and do A, 1 minus 1 equals 1. And what's 1 minus 1?
0.
There's your proof of why anything raised to the 0 power is 1. It's a weird fancy way of saying it's this number divided by itself. There's the proof. You see 0? Don't put 0. There will be an answer choice that says 0 for all those that like to put 0. I know with exponents we are talking about multiplication. The rule you were taught in like first grade is anything times 0 is 0. But anything raised to 0 is always going to be 1. That's what? You're divided by the number itself. Our last rule, negative exponents. Anything raised to a negative exponent Somebody sometime somewhere decided I don't like negative exponents, so I'm going to make it a rule that all exponents have to be positive. Well, how do you turn this into a positive exponent? Let's look at it as a fraction. Oops, b to the negative 1, or b to the negative n over 1. Remember the reciprocal? If I were to take the reciprocal of this, I get 1 over b to the n, or what happens with the exponent? It turns positive. So negative exponents is just a way of keeping yourself from working with fractions, but it is essentially a positive fraction. So here, I have x to the negative 2. That's the same as writing what? As a positive exponent. X squared? Where does
Oh,
it?
yeah. X squared. Right? X squared.
1 over x squared.
Up.
Opposite. You got to flip it. You got to drop it down to the denominator. So, that's how you turn negative exponents into positive exponents. It drops down to the denominator. And if it was in the denominator, say I give you this, oops. For example, 1 over 2 to the negative 8, that's the same as saying 2 to the 8. Crazy, huh? You know, remember 2 negatives makes a positive? It's kind of what happens. A negative in the denominator, and then the negative as an exponent. 2 to the negative 3, I can rewrite that as a positive exponent as 1 over 2 to the 3. Or 1/8. All right, let me give you a couple minutes. Work these problems at your table. Let's go over these. So, x squared y to the 4th power. What rule am I using? The multiplying, the divide, the power rule, or the rule of 0?
Power.
Power, which says I do what with the exponents?
You have to add them.
Oh wait,
You have to add them.
Right?
multiply.
Multiply. Power raised to the power, you multiply, right?
Oh,
Eight.
I'm thinking about the
So this is, yes, x to the 8 times 4 is 8, y to the 4.
Oh my gosh. Well, the
Also,
bottom
then
one.
Think about this, x squared. X squared repeats 4 times. 8. Y repeats 4 times. 4.
I thought that was asking you.
And on the bottom, we're going to use the power rule again. How many x's do I have on the bottom?
2,
How many y's?
2.
Very good. So I successfully did the power rule. What's the other rule I need to use to simplify this?
Subtract.
Subtract. Well, yeah, I need to do the division rule.
Dividing.
So x,
Is 4. Wait. A minus.
what I do with the exponents when I'm dividing?
You
You just tell me.
subtract.
Subtract. So 8 minus 2 is
Yeah,
4.
6.
6.
6. Watch out, you're not going to divide the
I was
exponents.
looking at the top.
You're subtracting the exponents. And then the y, how many y's?
2.
There are 2 left over.
Wow. It's just so easy when you do it.
That's why you got to do it
So right.
until it comes easy.
I thought I was wrong. Oh,
There's another one, the numerator.
We'll get to that one.
Let's follow our order of operations. What should we do inside the parentheses first?
Multiply. Oh wait.
What do you, yeah, they are multiplying, so you do what with the exponents?
Add them.
You add them. x8 squared over x9. What rule do we want to do next?
The exponent.
Yeah, a power raised to a power, which does what with the exponents?
Multiply.
Multiplying
So it's x and then 16.
over x9. One more rule to go. Subtract x to the
So it comes out to be
7. X to the 7th power.